Let's start this by creating some triangles. So we have the angle of depression from the top of the shorter building to the bottom of the other. So the angle of depression is always the angle from the horizontal downwards, right here. So this angle is 33 degrees. And this would make a right triangle. The horizontal is always parallel to the ground, which we would have here if we need it. And we're looking for the distance from the top of one building to the top of the other building. So that would be the hypotenuse of a right angle triangle. What are we given? We're given the height of both the buildings. This is 20 meters, and the height of the other building is 35 meters. So if we need it, this whole height is 35 meters. To solve for this, we could see that the 20 meters would be actually the same from here to here. So that allows us to get the side length of the top triangle is 15 meters. So to solve for the height, we would need either this angle or this side length. So we'll see which one is easiest to find. Well, this side length could be found given the ratio of tan of 33. So the tan of 33 degrees equals the opposite 20 over the adjacent. Let's call this x. Therefore, x equals 20 over tan 33. And so we could find that on the calculator, or we could just leave it for now, because that's our x value. So we know what x is because we just found it here. And so given this side length and this side length of a right angle triangle, we can use Pythagorean Theorem to solve for the hypotenuse. So a squared plus b squared equals c squared. So let's say a is my x. So we found that was 20 over the tan of 33 squared, and you could solve for that decimal and put it in, but I'm just going to use everything. Squared equals c squared, which we called h squared. We'll isolate for h squared, which equals all of this on the calculator would give us 0.5, and then square rooting both sides, plus or minus the square root, but we'll only use the positive version, 34.3 meters for the hypotenuse.